Hi everyone, my name is Susanto. I am from SMA 1 IPABI, and today I'm going to discuss about ion. So the things that I'm going to discuss about ion is types of ion, Lewis dot symbol, chemical bonding, types of chemical bond, and Lewis dot structure. So there are two types of ion according to the charge and according to the number of atoms. According to the charge, there are cation and anion. Cation refers to positively charged ion, while anion refers to negatively charged ion. And according to the number of atoms, there are monoatomic ion and polyatomic ion. Monoatomic ion is an ion consisting of only single atom, while polyatomic ion is an ion consisting of two or more atoms. So here are some examples. Number 1, ammonium ion. So the chemical formula of ammonium ion is NH4+, and as you guys can see here, it's a positively charged ion, so it is cation, and it has more than one single atom, so it is considered as a polyatomic cation. Examples number 2, phosphide ion. The chemical formula of phosphide ion is P raised to -3. As you guys can see here, it's a negatively charged ion, so it is anion, and it has only one single atom, so it is considered as a monoatomic anion. The last example is number 3, phosphide ion. The chemical formula of phosphide ion is PO3 raised to -3. And as you guys can see here, it's a negatively charged ion, so it is anion. And it has more than one single atom, so it is considered as a polyatomic anion. Now, before we're going to discuss about Lewis dot symbol, I'm going to explain a little bit about octet rule. So what is octet rule? Octet rule is a chemical rule of thumb that reflects the theory that main group elements tend to bond in such a way that each atom has 8 electrons in its valence shell, giving it the same electronic configuration as a noble gas. Now let's move to Lewis dot symbol. So what is Lewis dot symbol? Lewis dot symbol is the symbol of an element with one or more dots representing the valence electrons of the element. So here are some examples of Lewis dot symbol. First, aluminum. So first, let's find aluminum on the periodic table. And it's here. So aluminum has 1, 2, and 3 valence electron. Now, let's make the dot first. So, aluminum, 1, 2, and 3. And this helps me to understand that aluminum is more than likely going to give up 3 than to lose 5. So it's gonna tend to have a 3 plus or 3 positive charge. The next, number 2 is chlorine. So first, let's find chlorine on the periodic table. So here is the chlorine. So there is 1, 2, 3, 4, 5, 6, 7. So there is 7 valence electron. And let's make the dot first. 1, 2, 3, 4, 5, 6, and 7. So from this, by looking at this, I can tell that chlorine is going to gain 1 because it's easier to gain 1 than to lose 7. And by gaining 1, it's got a negative 1 charge. So now, let's recap about the Lewis dot symbol. So first, how to do the Lewis dot symbol, you have to write the element symbol, and then determine the valence electron, and last but not least, draw dots around the symbol following the pattern. Next, I'm going to discuss about chemical bonding. So, chemical bonding happens when 2 or more atoms join together to form a molecule in order for each atom to become stable. So, there are 2 types of chemical bond. First is ionic bond, and second is covalent bond. So, ionic bond happens between a metallic and non-metallic ion, while a covalent bond happens between non-metals. Ionic bond basically transfer electron, while covalent bond basically shares the electron. So here are the classic examples about ionic bond between sodium and chlorine. So sodium here is a silvery metal and has 1 valence electron, while chlorine here is a yellow-green gas and it needs 1 electron to fill its valence electron. So if we put them together, then they will burn as electrons are exchanged. So now the ions have the opposite charges and are attracted to each other by electrostatic force. Next, here is the example of covalent bond. So when these 2 hydrogen atoms get close enough together, the attraction is balanced in both directions, and then they share the electrons between them. Hence, a covalent bond is made and hydrogen gas is formed. Next, I'm going to discuss about Lewis dot structure. So, Lewis dot structure are diagrams that describe the chemical bonding between atoms in a molecule. So there are 2 Lewis dot structure. First is for ionic compound, and second is for covalent compounds. So here are the example of Lewis dot structure for ionic compounds. So first, let's separate this 2 and A, and then Cl. Okay, so next we need to figure out how many valence electrons each of these elements has. So in periodic table, sodium has 1 valence electron, so let's put the dot first here. And then chlorine has 7 valence electrons, so 1, 2, 3, 4, 5, 6, and 7. And then we said before that in ionic compounds, the metal would transfer to the non-metal, so we're going to transfer this 1 valence electron in sodium to the chloride. Erase this and add 1 here. So now the chlorine has 8 valence electron, while the sodium doesn't seem to have any valence electron. But actually the shell underneath is full, so it has a full outer shell. And because sodium lost the valence electron and electrons are negative, so it becomes positive. So we'll put here a plus. And then the chlorine, it gained that electrons are negative, the chlorine is now negative. And by convention, we should put brackets around the ion, the negative ion, sometimes positive too, so it will turn out like this. So here is the answer. And then next question is an example of Lewis dot structure for covalent compounds. So the same like before, we need to separate this since there are 2 bromine. need to figure out how much valence electron from the periodic table. So bromine has 7 valence electrons, so let's make the dots first. 2, 3, 4, 5, 6, 7. 1, 2, 3, 6, and 7. And then we can arrange and connect these atoms using a circle, so it will look like this. So the dots here, we transfer it to this, so here, and then the X here, transfer it to here. So now it's going to look like this, and when these elements get together, this is gonna represent the single bond. You can also write it this way. So in here, we change this one into a line, and now this is what we call a single bond. Okay, so next question. Question number 2. So this is an example of Lewis dot structure for covalent compounds. First, we need to separate the elements like before. O, C, O. And then check the valence electron from periodic table. So oxygen has 6 electrons, valence electrons. So 1, 2, 3, 4. 5, 6, 1, 2, 3, 4, 5, 6. And then carbon has 4 electrons, so 1, 2, 3, 4. And then we arrange and connect them with a circle like before. Since there are 3, so we made 3 circles here. Then put the dots here. And then you can just put the extra dots on this side. So now, when these elements get together, this is gonna represent a double bond. And you can also write it this way. So now, this is what we call a double bond. Double bond. And then next, in summary, single bond is a chemical bond in which one pair of electrons is shared between two atoms, while double bond is a chemical bond in which two pairs of electrons are shared between two atoms. So that's it, guys, for today's meeting. Thank you for your participation.